Hello everybody, I hope you are well. Today I'm going to solve another problem in structures of statics by Meriam. Here you can find my WhatsApp and Telegram phone number and also my ID on YouTube. I'm going to solve the problem number 25 of chapter 4. It's about analyzing the force of each member by analyzing joints. First of all, and the truss that I'm going to solve is a truss with 3 pulleys. Whenever we want to solve a truss with some pulleys or other stuff, it's better to disconnect all stuff such as pulleys from the truss. Now I called this pulley as a pulley number 1, pulley number 2, and pulley number 3. And also this truss has some reaction forces. For example, here we have D of x, and also D of y, and here we have E of x. And also here we have a tension if we cut this rope from this position. This tension is T. And you see, because all these 3 pulleys have neglected mass, so we consider T in each position of this rope. Here T is the summation of f of y for the mass of L, so equal to the summation of f of y is equal to 0, so T is equal to L. You know, this truss is a rigid, 2-dimensional rigid body. So as I said, this truss is a 2-dimensional rigid body. For the truss, we can write 3 equilibrium equations. The summation of f of x is equal to 0. The summation of f of y is equal to 0. And also the moment of over, for example, at the point D is equal to 0. For the last one, I can write that you can see D of x rotate truss in negative direction over the D. So I can write minus E of x divided by, multiply 7 and positive L multiply 3 multiply 8 and t sine of 45 degrees multiply 8, because but we cannot write the last term that I've written. We cannot write this term because if we find the component of t in this position, this and this, the distance is not correct. This term we cannot write this, and I think there is no need to find reaction forces, because as I said, we have to analyze joints one by one, and we can find a joint with two unknown parameters such as a, so there is no need to find reaction forces. We omit this term here. For finding the forces of all members, first of all we analyze zero force members. As I said in previous problem, if you consider the joint C, you can find that CF is equal to 0, because no force, no external forces acts on the C, so, and BC and CD are in the same direction, so we can consider CF as a 0 force. And also if you analyze E, here we have E of X, and here we have, for example, FC, and here we have ED. And if you write the summation of f of y is equal to 0, you can find ED is equal to 0. So we can say ED is equal to CF is equal to 0. And you can see this is correct. And now I analyze the pulley number 1. For pulley number 1, we have L here and also L here, and we have two unknown forces. For example, A of y and A of x. If we write the summation of f of x is equal to 0, because we can say minus f a of x plus L, because this angle is 10 degrees, cosine of 10 is equal to 0. So A of x is equal to L cosine of 10. That's it. And if we write the summation of f of y is equal to 0, we can say that a of y minus L sine of 10 is equal to 0. So a of a is equal to L plus L sine of 10 means L multiply 1 plus sine of 10. This is cosine 10 means 0.985 L, and sine of 10 means 1.174 L. So we should put the reaction of these two forces on the joint A. If I want to analyze joint A, I should write that, these two forces are noun, so I should write that A of y 1 point L in this direction, and A of x in this direction. And we have two unknown forces AG in this direction. AG, I consider it in this direction, and AB. As I said, when we consider AG in this direction, we should put the reaction of AG here. And in this situation, we consider AG as compression. It's under compression. For AB, when we consider it in this situation, we mention it as a tension. AB, it's under tension. AB tension and AG compression. And this is joint C, and we don't have any other external forces on joint A. So here we go. C is a joint, and this is equilibrium of particle or concurrent forces. We have only two equilibrium equations. The summation of f of x is equal to 0, and the summation of f of y is equal to 0. And this is x and y directions. So the summation of f of x means 0.985 L minus AG plus AB. And as you see, we consider it alpha. Tangent inverse of alpha is equal to 7 divided by 8. Means alpha is equal to 41 degrees. AB, this is alpha, cosine of, and in x direction we have only 3 forces is equal to 0, and the summation of f of y minus 1 point and plus AB sine of alpha. The last one we can find AB. So sine of means AB 1.783. It's correct, I think. 1.783. No, 2, but I think 3 is more correct because we use, after 2 we have 8. By the way, we put it in the first equation, so we have so AG is equal to 2.327 AG. Two, 2 point, and we consider it AG as a compression, and it was, we can find it as a positive amount. It's correct, and this is tension. Now for joint G, we are going to analyze point G. For G, first of all, I think there is no need to open the pulley number 2, so we consider it but it's here we have BG, and also we have AG. AG was compression, so we should consider it as this direction, AG, but AG is noun. AG 2.33 L, and we have GF, and also we have two noun tension of T in this direction, L and L. So we use the summation of f of y is equal to 0, and also we have the summation of f of x is equal to 0. But for the second one, we can write that BG minus 2L sine of 10 is equal to 0. So we can write that, or 2 divided by, multiply sine of 10. Three, 4, 7L. And we can, and from the free body diagram of the pulley, you can see that GF has to be equal to AG. From symmetry, you can see that symmetry GF is equal to 2.33 L, and it's under compression. And if you write the summation of f of x, you can find out it's correct. Now we can, because it's all these four members are nouns, we can analyze the joint B. Joint B. For B, there is no external forces, so we have AB, GF and AG. For AB. 1.783 L tension. So B and for BG is tension again. BG and we have two other unknown members, BC. Let's consider BC as a tension and BF as a compression. BF, excuse me. We have to the summation of f of x, the summation of f of y is equal to 0, x and y. So the second one or the first one, there is no difference. BC minus BF and the angle 7 this is alpha again, so this is alpha, means BF for summation of x cosine of and BC BF minus 1.783 L. This is alpha, yes. Cosine of is equal to 0. And the summation of f of y, BF sine of minus is equal to 0. So we can find BF. Divided by sine of alpha. Two point 31 L. BF BF, it's wrong. 1.25 BF. The summation of f of y BF sine of minus we should check just a moment, please. The problem is about BG. Here we consider BG in this direction. This is here we analyze the pulley. So when we consider the force that acts on the joint, we should put it in this direction. For member, excuse me. This is for pulley. For joint, we should put it here, and for member, we should put it here. We have three parts. One of them is joint. For joint, we consider it here, and for for pulley. And for joint, we should consider the reaction force. This is for joint. This is for pulley. And this is for member. And you can see that member is under compression, not tension. And we should correct the direction in this way, because BG is under compression. And when we consider it as a, excuse me, it's about C. For this direction, we should consider it in this direction. Here we should use it positive. In this situation, we have 1.783 sine of minus divided by sine of, just a moment please, again, so and divided by here we have and you can see that for BF it's compression. .25, it's correct for BF. And for BC, you know, the problem was about considering noun forces, the direction, considering noun forces. In joint analysis, if we consider unknown forces in a wrong direction, we can find negative amount. And in this situation, we can find out that we consider it as a wrong direction. But for noun, please be careful about noun amount, noun parameters, noun forces. For noun forces, we have to consider them in free body diagram in the right direction. And if we make a mistake, we cannot find the correct answer. For BC is equal to 2.287. For BC 87 or 2.29, and its tension, its compression. Now we find these two members, and now you can see that here these two forces are equal, means BC is equal to CD. BC is equal to CD, so it's equal to CD. Because BC and CD are in the same direction. Only three members remain. Let me check. ED, yes, it's okay. And I think I found it. The only two member are left. We have to, I think, we have to open F. For F, I draw free diagram here, and then I move it to another position. First of all, I mention noun forces, GF is, where is GF? 2.33 L compression. We found it, and I can use it here, but GF, I should, where is GF? GF, BG, GF. Okay, 2.33L compression. So for GF compression, 2.33L. And for BF I can use from this here, BF 1.255 LC, 1.255 LC here. And now before that, it's better to but we can do it, I think, because we need only, and I consider the pulley here, and we have two other forces. One of them is L, and this direction, this angle is 445 degrees. And also here we have L, and this is 10. And only, and this is 0. And only we have here as a compression FE and tension FD. That's it. I cannot. The problem is about cutting this and put it here, and I try to write just a moment, please. I'll copy, paste, but we don't need okay. So x and y, the summation of f of x is equal to 0. 2.33 L. L cosine of 45 minus L cosine of 10 to L and 7, 8 means here we have alpha plus L cosine minus L10 plus 1.255 L cosine 41 186 and minus FE plus FD cosine of alpha again is equal to 0. For summation of f of y, we have fd sine of alpha and minus 1.255 sine of alpha again, and minus L sine of 10 and minus L sine of 45. The last one we can, from the last one we can find FD. $1.255 sine alpha plus sine 10 plus sine 45 divided by sine of 45.6 means 2.59. DF is correct. It was DF, yes. Yes, DF. It was DF. And we consider it, or FD, as a tension. And we can put it here. We can find FE. So 2.33 cosine 45 minus cosine 10 plus 1.255 cosine alpha cosine so 2.33 cosine 45 minus cosine 10 plus 1 point cosine alpha plus 2 point cosine means 948 compression. For FE compression, we could find all members, the force of all members. As you see, I write all problems online without any other papers, or sometimes it's the first time, as because some of these problems are new for me, and because I have solved many problems in static from the previous version and also this version, this revision of or version of book, and it's online, and sometimes unfortunately I make mistakes, but I try to find my mistakes, and it happens for you sometimes that you want to solve these kinds of problems, and it's better to check your calculation again and again to find your mistake. And as I said, you should be careful for noun forces, because we don't have any problem with unknown forces, because we can find negative amount for them, so we can find that we consider the direction of them wrongly. Please be careful, and that's it. Have a good time and see you soon in another problem. Bye.